Hey guys, so last time we talked about earthquakes, and so this one we're going to be talking about what can result from earthquakes, and this is going to focus on tsunamis. And so last time we were looking at earthquakes, a lot of the normal fault, reverse fault, the strike slip fault, those things happen pretty much on the surface. When we're talking about a tsunami, what's going on is below the surface. And so if you remember our subduction zones that we learned about a lot of weeks ago, this is where these can be a major threat. And here's an example of a tsunami. Went across the Indian Ocean and did tremendous damage. And so you can see that this is where the epicenter of the earthquake took place. And then these red areas are where the tsunami wave um, took off um, and affected these areas. And it's just unbelievable. So this happened in Sumatra, off the coast of Sumatra, December 26th, 2004. And it was about a 9.1 earthquake right off the coast. And that tsunami wave traveled 375 miles an hour in 75 minutes. So that was going about 300 miles an hour. So you can see just a devastation here. These are huts and villages. You can see this is what an aerial photo before the tsunami went through, and this is after. So estimated killed 250,000 people, and just crazy. I mean, the earthquake killed people just from the structures falling, but then the tsunami came and it just added, as they would say, insult to injury and just devastated this area. And so here's some other pictures before and after. You know, these are some solid structures and then they're just gone. Just the power of these tsunamis is unbelievable. Here's some more pictures of it happening. And you can't really see it, but there's water that has gone through here, another area. So this ditch is right here, and just all these huts and villages, and just gone. And it's just super sad when these things happen. So, and here's the wave coming in of a tsunami. I'm assuming it's the same one. I think it is, but we're talking a 50-foot high wave in some areas, and in some regions it can actually, these waves can be 100 feet high. And uh, and the scary part is Oregon is predicted to have a major earthquake and a major tsunami to right off the of our Oregon Washington coast that could do some very serious damage. And we'll take a look at that today too. So what happens? How does this work? So here we have a normal wave, and so if you've ever been to the ocean, you see the waves just kind of going up and down, way out there. If you've ever taken a fishing boat out on the ocean, you can kind of feel those waves going up and down. And what causes the waves? Well, it's wind, really. I mean, the wind whips across the surface, and it starts to uh, water starts to be agitated, and it starts to raise the water. And so there's different parts of a wave that we need to know, and I'm sure some of you guys have learned this stuff before. But we have the crest, that's the top of the wave, the trough, which is the bottom, and then from crest to crest, or even trough to trough, uh, that's a wave length. And then we have this thing called amplitude. And so this is how high we were able to draw a line across the middle of the wave, how high above that, if it was like still water, how high above that. And as a wave from a tsunami starts approaching the shoreline, and even just a normal typical wave, it changes this wavelength and this amplitude. And we'll take a look at this next slide to show you. So you take a look at this. When the waves are out in the ocean, offshore, the water kind of does a circular motion, but these waves are not really, really high. And so wave frequency is not very far and the amplitude is not very far. But as we start approaching the shoreline, you can see that the shore itself tends to, if you want to think of it this way, it kind of slows down the underside of that wave, and it's going to increase as we de- in as we shorten that frequency. So that means we start getting more waves. It's going to cause the amplitude, the height of that wave, to begin to get bigger. I hope that makes sense to you. So as a wave is going, the land starts to slow the underside, and it starts to amplify and raise that wave. And we see this with normal waves, and that's why the waves break and they get bigger, and surfers love it when we get closer to the shoreline. Well, during a tsunami, what happens? Well, if we take a look, we said that these happen under breaking under the offshore. And so when we have those subduction zones, if you guys remember, we get a trench in the ocean. And that trench, if it builds up, it will, as the subduction zone happens, it will kind of bend the land and almost raise it up. Okay, and if the land gets stuck, okay, and then it breaks, all right, that water that is underneath where that trench is, it gets pushed up. And that pushing up of the water makes this big, huge wave that's out in the ocean. It's still not very big out there. Okay, but it starts to ripple effect. If you've ever thrown a rock in a still pond, it starts to ripple out. Well, that pushed up water starts to disperse everywhere around it, and it starts to ripple out across the ocean. And again, just like the other waves that we talked about, when it gets closer to the shoreline, it starts to slow down the underside, and it increases the frequency goes up and the amplitude goes up. And so we get this giant wave that goes inland. And so that's what causes a tsunami to happen. And so it's this deep ocean uplift, or even the footwall going down, or the subduction zone going down, that creates this huge wave out, bulge of water that gets pushed up, and then it starts rippling across the ocean. So, and we can see, like, here's a good picture, perfect example of me talking about throwing a rock in a still pond, and you can see these waves just rippling out. And out in the ocean, this is what's crazy. In the ocean, it's not, those waves, they'll be higher a little bit, but they're not, there's more water, volume of water to kind of help absorb it, okay? But as we start getting towards shoreline, it starts to get really high. And so one of the best things to do, if there is an earthquake that's close and you're at the beach and you have a boat and you're able to do it, is to get in that boat if you have time. This is the key. Some people, they'll get in the boats because they don't want their boats ending up inland, because that giant wave, once it hits inland, is going to take it. So they get in boats and they start running out to the ocean. And so they'll be able to see that wave and so on. But there have been people who pay attention to their science classes, and it has saved their lives. There's a story of a little girl who's on vacation in Hawaii, and if you look, that'd be right in the middle of where all of those waves are rippling in this picture. Hawaii can get affected by tsunamis. And so a little girl was on a field trip with her school, and she noticed that the water started rushing out. And so as that big wave starts to approach, the water inland starts to kind of rush out. And she started yelling at everybody, get up here, get to high land, get to high land. And people listened, and they got up there, and shortly after that, the big tsunami wave starts coming in, and she saved 30 or 40 people just by knowing what's going on. And so we can also figure out how fast the wave can travel. And so there's our equation. Don't worry, you guys aren't going to have any math on this, but one thing I want to point out is the distance away from where the epicenter is and how deep the water is will determine how big of a wave there is. And so When we start to look at Oregon now, we are expecting a large earthquake in the Juan de Fuca Cascadia subduction zone. And if there's a large earthquake, there's going to be a tsunami that goes with it. And so this is where we are expecting it. Historically, they have happened. And this week's assignment, I have some videos that you guys are going to watch. I'm going to get out of this for a second. And I'll put a link to this. You guys can read it. It's not part of an assignment, but this is the Herald and News. Next 50 years, they predict that a large earthquake and tsunami is going to hit this region of Oregon and Washington. So they talk about how often these earthquakes take place, and it's pretty crazy stuff. And so I don't know how many of you guys have ever traveled to the Oregon coast. Maybe some of you have seen these pictures right here. Tsunami hazard zone. In case of an earthquake, go to high ground or inland. And when you travel to the coast, you need to see these signs, and you need to be able to find where you can go and be safe. And I'm going to pick on Seaside, Oregon. I don't know how many of you guys have ever been there, but this is Seaside, Oregon, okay? And it is very, very shallow. It's very sloping town. The town is close to the beach. It's very beautiful. However, this website that I'm going to show you next, remember this picture, because everything in yellow is if we have a local earthquake and tsunami that takes place. Everything in yellow and orange would be underwater. And that town of Seaside, when that earthquake and tsunami hit, is going to be gone. And so if people aren't prepared and they don't know where they're going, this earthquake and tsunami, you're not going to have a lot of time to get to high ground. So if you feel the ground shaking and you're on the coast, get out of there. Get to high ground. Don't go up in a building. Get to high ground. And so these are some predictions about what the devastation to Oregon is going to be. That area of the state, our coast, is just, unless things change and unless Oregonians really, make some major changes, that area of our state is going to be very heavy damage. There's old structures, there's old bridges, there's all kinds of things that are just not ready for this. And one other thing that I want to point out too, on the Oregon coast, this is very landlocked, meaning there's not a bunch of highways for people to evacuate, and also for people to go there and help. And so scientists have been really alarmed and really trying to tell people for a very long time that this is happening. We need to prepare better. And your assignment this week is going to watch some of these shorter videos. I'll make sure you're fast forwarding, so I have the links on the assignment. Just watch for the duration. So skip the video to those times and then stop when it says. And then one major thing that I hope makes Oregonians and people think about is the 2011 Japanese earthquake and then tsunami and the devastation that took place there. And on this video, you guys are going to only watch the first 12 minutes. So some pretty crazy stuff coming. I know a lot of people are worried about the virus that's going on and those kinds of things, but Mother Nature does not mess around. And if we were to get 100-foot wave at the Oregon coast in some of these areas, it's just going to be horrible. So